Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Garlic Bread says hi to the VC.
Hey, we got Garlic Bread that's in here. Garlic Bread's VC verified, seems sincere. What's up, Garlic Bread?
Nothing much, just here to listen, doing some math.
Doing some math.
Yeah.
Is it, what type of math are you doing? Is it for your homework or what?
It's to study for exam.
Okay. Hey, what brought you to this topic of the server?
The Netflix documentation.
Okay. Are you for the Earth being a globe or against it?
Honestly, I don't really care too much. I just like hearing people discuss something. So here I am to hear people discuss something and sometimes talk myself. I don't really care for the globe or the flat Earth movement, whatever. I don't really care much about what is the truth because it hasn't directly impacted my life yet. So
Essentially, you don't care about truth.
The fact of the matter is it has impacted your life in a lot of ways that apparently you really don't care about. I mean, I don't like to be lied to. I don't know about you, but when you're lied to as much as they've done, I mean, it's sort of like it's disturbing. You know, I don't like to be lied to about anything by anyone. It really does rub me the wrong way. So I don't know how you get around that, to be honest with you.
I kind of just accept the fact that I'm getting lied to all the time, and then go out from my own, out from my own observations from that.
Yeah, but you do have your own mind to actually think about the world around you. So if you're able to figure things out, and you know that you can, why would you accept just that's the world around you when you have the ability to change things?
I mean,
you have that ability.
I have that ability, but it also comes with backlash.
Like what?
And it's not as just as much as I'm not that willing to fight for trans rights. I'm not willing to put a stance on a topic like this one.
Yeah, but this has to do with the Earth that you're standing on, not an opinion on what somebody is or isn't. Like that's not what this is. The Earth itself is displaying itself to you as what it actually is. So when you talk about this topic, God rockin', I think you're hot micing, brother. There's some weird feedback coming from your mic.
I'll turn it off. I don't understand that, but I'll mute.
Yeah, I just locally mute, and when you're ready, just unmute.
Yeah, I will.
So yeah, I mean this topic is of the physical and natural world, and it has more to do with what we've learned at school. So it has to do with education, it has to do with the really is level, if things are the way they're telling us they are or they're not. And so to be nonchalant about that is to say, what's the point, right? And we're telling you that the physical and natural world that you're living in right now can tell you with using your senses what it is. Like you don't have to, there's not a mystery, let's say. Right now, if you think of it like a mystery, then it becomes one. But if you say, let me just take a look at this, right? If it's possible that they're telling me I live on a planet, it's got curvature, it's spinning, there's a vacuum of space, people are going off and just all that stuff. If that's true, then maybe there's something I can discover on this Earth that makes it real. And you don't need to be a scientist to figure this out because it has nothing to do with science. Does that make sense, Garlic Bread?
Yeah.
Well, I mean, if it does, then I think a logical step forward would be, let me just take a look at it. You know, they don't have to be all invested in it and just argue with everybody, but you could just say, what are they presenting to me that I know that the Earth is definitely a globe, and I can say that 100%, you know. And if they don't have anything, well, that's fine. They don't have anything, right? But at least you have the ability to think about it that way. But I mean, this is the world that you live in. At some point, it's going to affect you in a way that you practically use the earth. Like when you navigate across the earth, how you speak about the earth, like something is going to be in your future where it's going to be utilized in a way that it makes sense to you that it's a globe or that it's not a globe, right? So it's practical too, because people that navigate across the earth either navigate across it like it's flat and stationary or like it's a globe. So practically, it can make sense to you. Like, you know, it's gonna be in your path either way. You're still gonna deal with it. So it's not like something like where you have an idea about what somebody is or isn't like that. You don't have to live in your life. It doesn't have to be in your immediate life, but traveling over the earth, that's in your immediate life because you go everywhere on the earth.
I mean, traveling around the earth, whether through flight or through sailing, it's been working out fine with the Glow Earth, way. I know they've been doing it on a flat plane as if it was a flat plane, but see, it works fine that way either way. So, and there's
do you believe that? Do you really believe that? Like I'm confused. I think that maybe you just believe that's true. I don't think you know it is.
I mean,
well, let's just challenge you, Garlic. Let's just challenge you on that point, okay? Jedi, if you're here, I don't know if you want to talk to him about navigation. If you are here, bud.
I'm not really willing to take a hard stance on anything.
I'm right here.
Well, no, that's fine. That's fine, man. Just if you can hear him out, how about that? Just hear him out, okay? On navigating on this earth, let's say using triangulation, the sextant. I don't know.
Who am I talking to, Miggy? What's the gentleman's name?
Garlic Bread.
Hello, mate. Hello, Garlic Bread. I'm Jedi. Pleased to meet you. How you doing?
I'm doing pretty great. Not gonna lie.
Awesome. Do you know what a triangle is?
Yep.
Awesome. You understand that a triangle is 3 straight lines that meet at 3 vertices and you get 3 angles at those vertices, correct?
Mm-hmm.
Awesome stuff. You can't measure an angle if one of those lines is curved because 2 of those angles will be disturbed, correct?
Yeah.
Awesome stuff. You see, have you heard of something called celestial navigation? Navigating across the earth with the stars. Have you heard of that before?
Yeah.
Do you know how that's done?
I mean, isn't it just finding the 4 different directions, south, east?
We always want to know yeah, that's going to be using a compass, and that's fine. But navigating using the stars, we know that the stars have throughout the year they return in the constellations, correct? So we know that they've got ground positions all over the earth. You look up, look straight down. That's where the stars are at a certain time of year. Because we know where the stars are at certain times of year, we can navigate across the earth. You know how that's done, right? We understand that we can do that, and we've done that for hundreds of years, sailing across the oceans.
Yeah.
Now, how we do this is by using an angle measuring device. Now, we know what an angle is. We've just spoken about triangles. So, you know what a protractor is. You find them in stationary sets, yeah? You know what a protractor is?
I don't know the word. I'm from another country, sorry.
Okay.
But I'm guessing you're saying is that like 2 points in the sky and then you're the third point, making a triangle?
Yeah, no, let me do it like this. So you would have a device called a sextant, which is a glorified protractor, which is an angle measuring device. It's the type of thing that you put down on a piece of paper with a drawing of 90 degrees on it, and you put the center on the middle of the 90 degrees, and you got your 2 lines, and you got your 90 degrees, and that's how you measure your angle. You put it on a triangle, you measure the angle within inside the triangle. Within celestial navigation, what you do is you stand on the surface of the earth, and you point up elevation to the star, and you point outwards towards the horizon. The difference between the horizon and the angle up to the star is what you're trying to measure. It's called your elevation angle. Now, below the star is something called a GP, the ground position of that star. And that star can be beyond the horizon up to a distance of 3,000, 4,000 miles in the case of Polaris, for example. So Polaris can have a ground position 3,000 miles beyond the horizon and have 90 degrees directly underneath Polaris. That's straight line down from Polaris, touching the Earth's floor, ground position, and then a straight line to you, 3,000 miles away with your sextant. what we do is we'll put the sextant on the floor because there's a correction for how high above the surface of the earth you're going to be. Say, for example, 14 foot, 20 foot. You're going to retract that down to 0. But ultimately what you're doing is you're drawing a triangle. You up to the star, down from the star to the surface of the earth to the ground position, and a straight baseline to you. Now, to use this angle measuring device to navigate across the earth using celestial navigation, the earth must be flat. It cannot be curved, for example, because that flat baseline would interrupt two angles, your angle up to the star and the angle of the GP underneath the star. So the earth is required to be level to navigate across the earth using angle measuring devices, because if the earth was curved, we wouldn't be able to use angle measuring devices. They would be non-applicable. You understand that?
Could you repeat that part again?
To navigate across the earth using angle measuring devices, the earth must necessarily be flat, because if it was a curved surface, you would not be able to measure angles.
Didn't you say one of the lines had to be curved for the entire thing to be ruined?
No. One of the lines would be curved if the earth was a ball, and that would be the baseline, the one between you and the GP of the star, interrupting two angles. As in, you wouldn't be able to measure the 90 degrees GP below the star, because your curved line would intersect there, and the curved line would intersect with you, with your sextant on the floor. You wouldn't be able to measure your elevation angle up to a star. So if the surface of the earth was curved, we wouldn't be able to use angle measuring devices. We wouldn't be using what's known as celestial navigation.
Yeah.
So therefore the earth is required to be flat and cannot in any way be a ball. Well, considering we're navigating across a flat earth with tools that require the earth to be flat, then the earth is necessarily navigated across as a flat surface and not a curved one.
Can't say too much about that.
You know what a triangle is.
Makes sense. Yeah.
Yeah.
I know what I'm trying to work towards, but like, a lot of your statements disproves globe Earth, while a lot of globe Earth statements disprove flat Earth.
No.
Well, which one would disprove celestial navigation requiring angle measuring devices necessitating the surface of the Earth to be flat? What do they say about that?
Can't really find anything right now. I'm not a geologist.
Not geology, this is geometry. I get that English is your first language, buddy. But yeah, geometry. It's just math.
What globe arguments debunked a flat Earth? That's what I'm interested in.
Well, globe arguments, they're not really against flat. They just kind of take a stance.
Okay, what are they?
That's my stance against flat Earth.
Right. Can I quickly interject? Please? You see what Chris Jedi's laid out for you there is something that is demonstrated in practicality. It can be used for a practical purpose in order to achieve an actual result which benefits you. In this case, in finding where you are, right? Finding it so you don't get lost or something like that. So what would there be for the globe where it's a necessity that the surface of the Earth must be curved in order to achieve some practical purpose and benefit you in some way?
Not really anything.
Strange, yeah.
Garlic bread.
Yeah.
I mean, me and you haven't spoken for long. I don't know if we've spoken much before. I can't remember. I don't know how long you've been in the server, but forgive me if this question is poorly phrased, but what's keeping you on the spinning ball in a vacuum of space?
I mean, I have been here to talk about the gravitational pull before, if that's what you're working towards.
No, I was just working towards what's keeping you on the ball, not as in what's physically keeping you on the ball, but what is
Yeah.
keeping your mind entrenched in the idea that this is what the Earth is.
Yeah, what convincing argument?
It fits fairly well with everything else,
What?
so I'll just accept it for now.
Yeah, but what, though? What fits well?
The globe Earth,
What, though?
theory.
You're just saying globe Earth fits well.
Yeah.
What about the globe Earth fits
It
well?
fits well with the rest of the world theories about science, about atoms.
That's well with the Hollywood movies for sure.
All right.
Sorry to interrupt again, but what do you mean by fits well? So, do you mean by they've got lots of stories? As in, they give you a reason why sunsets happen and why eclipses happen, whether solar or lunar. They tell you stories about Mars and what happens up there. Do you mean by it seems to fit? A story that they tell you seems to fit with the story that they tell you.
It seems to fit with the other stories. It's like
Yeah.
Can you name one?
Name
a story. Tell us a story that fits well with the globe.
Yeah. And I'll do this as well. I'll help you out. When you're going to tell us the story, you'll realise that every single one is going to start with the presupposition that the Earth is already a ball spinning in space. But let's hear your story whilst the Earth is already a spinning ball in space.
It's funny you don't have one.
There are two sides of the night sky because we are living on a spinning ball because it's in a
Jedi, good prediction.
Yeah. What do you mean there are two sides to the night sky?
Yeah, I didn't get that one either.
There are some constellations that we can't see because they're on the other side of the Earth.
The ones that are behind the sun that you can't see because the sun's out, and the ones that you can see at night time when you can see stars, and the stars rotate constantly throughout the year and replace themselves continuously over a period of a year, because that's why they're called constellations. Even within the heliocentric model, right, this is easily explained, and in the flat earth idea, those stars are just behind the sun, exactly in the heliocentric model, which is the passage of time. Can't see those stars, they're behind the sun. No shit.
Yeah.
Yeah. So Earth's flat, can't see stars, it's daytime. No shit. What's the problem? You see, this is again maybe what we mean. It's either the Earth is already a spinning ball in a vacuum of space and continue your story, or whatever story you're going to tell us can happen on the flat Earth as well. Like Aristophanes. Oh, well, if you're going to have angles because of sunlight and you move away from where the first shadow wasn't cast and you find the shadow somewhere else, then that can only happen on a spherical surface. Like you've never walked down a street at night and watched a shadow increase as you walked away from one light that was over you at one point until you walked away from it. Yeah, it's either one of those two things.
And not one thing only works on a globe. Not one.
So again, garlic bread. Is it gravity that you think is one of those stories that, seems plausible, and the Earth can only be a ball if things go down?
Sounds like he's stuck there. He brought it up before, yeah.
Yeah,
Gravity.
makes sense to me.
Gravity makes sense?
Well, yeah. If Bohr's model of the atom is to make sense, then gravity is too. It's like
you're going to hate
me. We're talking about Earth, or we're talking about an atom? Go for it, man.
He's going to hate me when I say, when anybody says atoms, you do know that you're just referring to a model. This isn't the physical, actual reality of atoms. It's called the atomistic model. It's just a way of conceptualizing things that are really small. There's other ideas as well on the atomistic scale, where these things aren't actually physical. They're electric vibrations. Depending on the vibration and the charge, which is a better one, it's either closer or further away to the radius of the central point. But blah, blah, blah. It's just a model. There's lots of ideas out there that we don't know about, that we've just got ideas for, and we conceptualize them using models and conventions and so on. Like maths, for example, a way to explain this. It works.
I feel like these theories that, like the main theories that are presented to us in the schools now, is a hope for us to be able to further prove it by, getting the right calculations by using this theory.
Wrong.
So that's why we're taught it. But yeah, nothing is really confirmed.
But you're taught it as a fact, though, aren't you?
Yeah.
Yeah.
It's interesting as well.
That's the problem.
Yeah. So gravity, mass attracting mass, that'll be taught as a fact at school. But that'll change later, and they'll start talking about Einstein's and general relativity and the bending and warping of space-time. But they'll do that later at maybe university level. But the first indoctrination is contradictory to the second piece of indoctrination. See, this is what we get in here the majority of the time. If people aren't up to date with their own scientific rhetoric and just believe the brainwashing they got from school, mass attracts mass. So I'm still really interested. What would be keeping anybody to the idea that the Earth was a spinning ball in a vacuum of space? When presented with the evidence that we're not navigating across a ball with tools that would necessitate the Earth to be flat and could not be a ball in any way. We are not navigating across a ball using tools to navigate across a ball with, for example. You'd think we'd be doing that. So it's interesting to me when we point out that you can't have gas pressure without a container, and they declare the Earth to be an open system, how people can still believe that we're on a spinning ball in a vacuum of space. Kind of as the days and the weeks and the years go by, kind of beggars belief. It's like
There would be no gas left on the planet.
Wouldn't have
Sounds
even
weird saying that.
died. First bit of gas would have fucked off, closely followed by
Yeah.
all the rest of the gas.
Yep.
Well, now they're saying that. Now they're saying that some of the gas is being released into space. That's what I heard. The last thing I heard.
Yeah, they've been saying that for a while. We lose. They actually have a number as well. Fuck knows how they know that. Oh, I know. They just make it up.
Yeah.
If the gases were leaving, the liquid would change to gas to fill the space that the gas left behind. Eventually, all the liquids would go too.
Yeah.
Closely followed by the ice, which would sublimate and skip over the stage and turn into a fluid and turn straight to gas. Which then begs the question, how the fuck do you have ice rings around planets, gas giants, in the vacuum of space when ice sublimates in vacuums?
Sublimation. Yeah. Thanks for that one, Jedi. It was 2 months ago you told me that.
Yeah. I bring it up from time to time. It doesn't get talked about much. Don't really need to go there, but I just like to,
Yeah.
extra.
Because that exists in an imaginary place.
Yeah.
Or a container.
So the question then again back to garlic bread. Why do you still think you're on a spinning ball? And what would it take for us to show you the truth?
I mean, you already are. It's just, I don't think I'm gonna be one to take a hard stance on anything at this point.
That's fair.
Well, it's a bit of a cop-out to me. You either want to learn something. Since you've found out about this subject, have you looked into anything?
Nope.
How long ago? Sorry, here's my question then, because I might have to take my previous statement back. How long have you been looking into this?
How long have I been looking into this?
Yeah, Flat Earth. How long have you been visiting the server? How long have you been listening to people talk about it or watching YouTube videos, for example?
About
How
6
long?
months.
Yeah, 6 months. Okay.
I
See,
joined the server 2 years ago, actually.
Oh, wow. Okay. Why did
Different
you
story.
join
Maybe
2
it is.
years ago?
Wait, hold on. You can see that on my profile. Actually,
Yeah,
don't remember.
that's fine.
Maybe he
Yeah.
wants to keep it on the private. You can do that. You can know about this stuff and keep it mostly in the private. You don't have to wear the Flatter hat and the shirt and go out there and say, "Hey, Flatter."
Stop.
You don't. You can keep it on the private.
That wasn't the question.
That was my comment about the whole thing, about what he's saying. It's valid.
Oh, okay. Yeah. I get you now.
I remember.
Are you in uni? Sorry, I was just going to ask him if he's in uni. What level of education is he at the moment?
High school. Or the equivalent of high school.
What's your preferred vocation? Where you headed with it? Do you think?
I think bioengineering.
Oh, yeah.
Okay.
A real science.
Took biotech in 8th grade, and then it was like a class that kept going through 8th grade to 3rd, or like to senior year high school.
Would you say that you know what science is then?
No.
You don't know
I
what
mean,
science
I know the
is.
scientific process, but I don't think I have enough information or knowledge to say exactly what science is.
Well, science is kind
That's
of...
it.
Yeah, science is the pursuit of knowledge, primarily in the physical and natural world, where we answer the question, what the fuck caused that then? Because we observe things to happen, and our question is, what caused that? Science deals with cause and effect relationship, hypothesis-based. Your supposition into what cause affects, and then you physically test it in an experiment. That's just a method of science. Kind of baffled me a little bit when it's like I've been at university for God knows how long, been through high school, and God, I still don't know what science is. It's this huge, massive thing that I must take years and years to learn. But science is really easy. It's just a fucking method. We figure it out at year 7, 5th grade, whatever, really young, beginning of high school, at school. How to build a hypothesis. Let's boil some water. That's what science is. Now, there's different branches of science, I'll give you that. And within those branches of science, yeah, shit gets complicated, get you. But, for example, when we, as in the world, are told that science has proven the shape of the Earth, it's poignant to understand what science is, because you might realise you're having the wool pulled over your eyes, because science isn't the tool you're going to be using to answer the question what a shape is. As I said earlier, science, cause and effect, what the fuck caused that to happen is the primary question in the scientific method, not what is it. So yeah, I like asking students of sciences if they know what science is, because more often than not, Garlic Bread, they kind of give us answers like you just have. Wow, it's massive. I haven't quite got there yet. The gurus and the wizards haven't quite given me all of their secrets.
That's pseudoscience.
Yeah.
Do you know what pseudoscience is? Garlic?
I don't know the definition.
Well, it's just science that doesn't follow scientific method.
Oh.
So fake science, not real science. So there must be an there must be an actual science
Theoretical
to begin with.
physics, theoretical mathematics.
Well, mathematics is not science. That's a tool for science, but it's just a language. But astronomy, astrophysics, they're all pseudosciences.
If it doesn't have a hypothesis test, an experiment, then it's not science.
Spartans! What is your profession?
See, old friend, I brought more soldiers than you did.